Hey y'all, this is Mr. Smith. This is a video on line of best fit, correlation, and residuals. They all kind of go hand in hand together. So in this example, we have the table shows the time length it takes to clean Bojangles Arena. I've already labeled my top column my X, my top row X, and my lower row Y. It's always a good habit just to go and write X and Y, just so that you always have that reference to go back to. So the first part of this question is to find the equation. So to find our equation, we always want to use our calculator. So the first thing I'm going to do, I'm going to go ahead and clear my calculator. So in case you forgot, it is second plus 712, and that's what I want to type in. So second, I'll slide it up a little bit so you can see the key presses, and then plus, and then 7, then 1, and then 2, and that just resets my calculator. So now, in order to type this table in, I'm going to hit the stab button. I want to press enter on edit, and now I can type in my table. So my L1, which is the first column, would be my X, and then my Y is going to be L2. So I'm just going to type in those numbers. So we have 7, 11, 13, 17, 27, 40, and 57. And then we have 20, 12.5, 12.3, 10, 7.5, 7, and 1. So now that I have all that typed in, to get my equation, I'm going to go back to stat because I need to do a calculation. So I'm going to go over to calculate, and we're trying to get an equation. So we're going to use linear regression, AX plus B. And then you're just going to enter through all these options and go over to calculate. And there's an equation, or there's our equation. So I'm going to go ahead and write y is equal to negative 0.293 x. I'm just going to keep 3 decimals for accuracy. And then plus 17.247. And that would be our equation. So y would be the total time to clean, and x is going to be the number of people. So part B asks us, what is the meaning of the slope? So in order to find the meaning of the slope, we have to know what the slope is first. So right here, we know the number in front of x is our slope, because we know that is m x. So that means our slope is negative 0.293. So what that tells me is that for every person, the amount of time to clean, and will it increase or decrease? Will the amount of time increase or decrease? It will decrease by 0.293 of an hour. So for every person that helps to clean, the amount of time to clean will decrease by 2.93 of an hour. So the total cleaning time will decrease for every person that in addition that comes. Um, the next question is, what is the correlation between the number of people and cleaning time? So to find correlation, they're referring to strong positive, strong negative, weak positive, weak negative. And we can actually use our calculator to do that. In order to do that, we have to turn on our diagnostic. So our diagnostic is going to be underneath our catalog. So if we go to second, which is the blue key, and then catalog, we can keep pressing down until we get to the D's. Or when we first press catalog, we can simply press D, which is x to the -1. See right here? So if you just press that, you go straight to the D's. And then we're going to go to diagnostic on, because we're going to do some diagnostics on it. And then just press enter and it will say done. And then from there we're going to go back to stat, over to calculate, and we're going to go to linear regression again. So we're going to recalculate how we got our equation. And then we're going to go down to calculate again. And bam, as you can see, we have two new values. We have r squared and we have r. We want to just use the r, and anytime this r is 0.85 or larger, we call that a strong. And since it's negative, we call this a strong negative relationship. Alright, so I'm going to write strong negative. I'm going to write what the r is first. So r is negative 0.91. Therefore, we have a strong negative relationship. Cool. Any questions? Just kidding. Anyway, we go down to D. It says, if the stadium has to be cleaned in 8 hours, how many people are needed to help clean? So this, we're just going to use the equation we have, y equals negative 0.293x plus 17.247. And we're going to plug in our 8. So the point where most students make a mistake is where they don't know where to plug it in. So they give us 8 hours. So when we look at 8 hours, we have to decide, are we going to plug that in for x, or are we going to plug it in for y? So when we say 8 hours, is that the number of people? Hopefully you don't think we number people in hours. It's the actual total time to clean. So we're going to plug in 8 for y. So we have 8 is equal to negative 0.293x plus 17.247. So all we have to do now is solve for x, and that will tell me the number of people, because x is the number of people, and they ask how many people. So we're going to subtract 17.247 on both sides. And so on this side is the easy side. All we have left is negative 0.293x. And I'm going to pull out my calculator, and let's subtract 8 minus 17.247, and we get negative 9.247, and then we'll divide everything by negative 0.293. So we're going to divide our answer by negative 0.293, and we get 31.559. So we know, I'm going to pull it out over here. So we have 31.56 is equal to x. So we have 31.56 is our answer, but we want to know how many people are needed to help clean. So to really get 8 hours cleaning, we're going to need 30 32 people because we can't have 0.56 of a person. So we need 32 people. Alright, so in this problem, we've just finished answering all the true line of best fit questions. C was a correlation question, and E is a residual question. So we have to figure out, when we look at E, it says approximately what percent of cleaning time is more than 1 hour different from the time predicted by the line of best fit. So in order to do this, we're going to need our calculator. And in order to do any residuals, you always have to calculate the linear regression first. If you do not do this first, you will not get the residual column. So I'm going to go ahead and do this. Even though we've already done this, I'm going to do it one more time just to make sure it's in the system. And then once you do that, we go back to Stat. We go to Edit. And I'm going to move the cursor up to L2 and over to L3. So you need to highlight L3. Not here, but highlight L3. Once you have L3 highlighted, we need to go to List. See here how it's in blue? List. So to get the blue words, you have to hit the second key. So I'm going to hit second, and then List, and then RESID stands for residual. So I'm going to go down to residual, and then I just press enter, and then all this is my residual. So what I'm going to do, I'm going to copy all these numbers underneath my table, and that's just a good habit. So when you're taking the test, when you're on the EOC, go ahead and just copy the residuals down. When you copy the residuals down, it will allow you to visually see what is going on. So one thing that you're going to notice when I copy this down, I'm not going to copy the negatives. I'm just going to take the absolute value, or the positive version of everything. Absolute value just means take the positive version of it. So for the first one, put it right here so you can still kind of see. We have 4, let me get my pen to write. We have 4.805, and then we have 1.522, and then we have 1.136, and then we have 2.263, and then we have 1.831, and then we have 1.4809, and then we have 0.46551. And so the question asks, what percent of cleaning time is more than 1? So we're going to find all the ones that are more than 1. So when I look at this, I'm looking for the numbers that are more than 1. Sometimes this might say more than 0.5, more than 2, more than 2.25, but it says more than 1. So when I look at this, this is more than 1, 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 this is more than 1. So we have 1, 2, 3, 4, 5, 6 of them that is more than 1. So we have 6 that are more than 1, but we want to find the percent. So we got to figure out how many out of how many are more than 1. So we already know 6 out of 1, 2, 3, 4, 5, 6, 7. And then we find that what that is. So we want the decimal value. So I'm going to second quit. I'm going to do 6 divided by 7. And we get 0.857. And then to get the actual percent, we have to multiply by 100, and we can tell that 85.7% of the data is more than 1 hour different from the predicted line of best fit. And that's pretty much it. I really hope this video helped. If you need to look at it again, definitely look at it again, or ask your teacher. This is Mr. Smith again. Y'all have a good one.